Hello everyone. Today in this session we are going to discuss about how to instruct the computer to perform a given task. So we know the computer can understand only 0 and 1, but the input we are going to give are character codes and decimal number. But ultimately whatever the input we are giving, it will be converted back to the machine language, nothing but 0 and 1, and that 0 and 1 we call it as a binary number. So binary number is nothing but the string of bits 0 and 1, and similarly we have a character also, which is nothing but string of text. So string of text is nothing but character code, and string of bits is nothing but a binary number what we are going to give to make the computer understand. Today let's start discussing about the number representation, how we can give to the computer. So here we have taken a simple vector representation here, which is for unsigned number and which is having the range between 0 and n minus 1. So you can see the range is from 0 to n minus 1, and you are trying to represent this for unsigned number. So when we are saying unsigned, we say that it is for positive number, and this is the representation we have taken as v of b. By looking at a given number, we can say whether that number is positive or negative based on its MSB. If MSB is 0, that is a positive number. If MSB is 1, that is a negative number. So this is a general representation to make understand how we can say whether the number is positive or negative. Now we say the numbers can be represented in three forms. One is sign and magnitude, 1's complement and 2's complement. So already we know what is 1's complement and 2's complement. So let's start with sign and magnitude. In sign and magnitude, the representation is very simple. We say only by changing the MSB of the number we can get the negative form. For example, just think we have the number 0, 1, 0, 0. Since it is MSB is 0, I will say it is plus, and this is the representation of 4, plus 4. By just changing its MSB 0 to 1, I will get negative 4. I will say this is minus 4. So in sign and magnitude, getting a negative number is very easy only by changing its MSB. If we are changing the MSB from 0 to 1, we can get its negative form. So this is the table we have taken, where we have taken a 4-bit number. Since we have taken a 4-bit number, the combinations we get are 16. So for example, if you are taking a 2-bit number, I will represent it as 2 power 2, where you can get it as 4 combinations 0, 0, 0, 1, 1, 0 and 1, 1. Similarly, if you are taking 3-bit number, then a representation will be like 2 power 3, which is equal to 8 combinations. You will get it as 0, 0, 0, 0, 0, 1, 0, 1, 0 till 1, 1, 1. Similarly, now I have taken 4-bit combination, so it is like 2 power 4 is equal to 16. The number I have taken it as a vector, so the number, the representation I have taken it as b, right? So this is I am representing in the form of the vector, which carries the values, positions like b0, b1, b2 and b3. So representing this number like this, any variable we are representing like more than once, we call it as a vector representation. So now 16 combinations we have. So 16 combinations are like 0, 0, 0, 0 to 1, 1, 1, 1, right? So 2 power 4, we have a vector, we have a variable b, we have represented in its form of vector, which says b0, b1, b2 and b3. So values are 0, 0, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0 till 1, 1, 1, 1. So this is the table what we have represented here. So b3, b2, b1, b0. The variable you have taken b, we have represented in vector form, and we have taken the various combinations. So the combinations are we have defined clearly, but for the better understanding what we have done, we have separated them in such a way that the upper part, it is giving the number which are carrying MSB as 0, and the lower numbers are having the combination where MSB is 1. So in all the three representations, sign and magnitude, 1's complement and 2's complement, the representation for positive number is same. You can see here. The representation for positive number is same here to here. So you can see plus 7, plus 7, plus 7, plus 6, plus 6, plus 6 till 0. Right. Representing the positive number in all the three methods are same, whereas the difference comes when we are trying to represent the number in its negative form. So we said if you have taken a number and you are trying to represent that number in negative form, if it is in sign and magnitude, just change its MSB. 0, 1, 0, 1. This is positive number. If you want this to be negative number, change this MSB to 1. So it will be, you will get it as negative 5. 0, 0, 1, 0, 1. You will get it as plus 5. Change the MSB, you will get it as negative 5. If it is in sign and magnitude. If it is 1's complement, we have already studied this 1's complement. You have to take the complement of each bit. For example, if you have taken 0, 1, 0, 1, then complement form of this will be 1, 0, 1, 0. So this is negative number. You can just look at this table. You have taken the 1's complement number also here. We don't have any problem with the representation of positive number. Whereas if it is negative form, you have to take the complement of the number. So this is 1, 0, 0, 0. We have represented this number as minus 7 in 1's complement. How? Just take out the number. This is the input you have taken. In 1's complement, what you have to do? You have to take the complement of each bit. Then you are getting its negative form. That is why it is represented as minus 7. Similarly, the same number in 2's complement, we have given it as minus 8. You can see here. The same number, it is represented as minus 8 in 2's complement form. So how to find out the 2's complement of a given number? So to find out the 2's complement of a number, first you need to do 1's complement. Then you need to add plus 1 to this. So we will take out the same number 1, 0, 0, 0. The 1's complement of this number is 0, 1, 1, 1. Right? To make it 2's complement, what you have need to do? You need to add 1. So 1 plus 1, 0, 0, 0, 1. So what is this number? 8. Which 8? Minus 8. So the same number you had taken, right? In the previous case, in 1's complement, the 1's complement of this number was this one. This was minus 7. Right? If you want to find out the 2's complement, you need to add 1 to this. You got this number. So this is minus 8 and this is your 2's complement. The same number 1, 0, 0, 0, in different method it is represented in different form. If it is in sign and magnitude, it has given as minus 0. If it is in 1's complement, we have given it as minus 7. And if it is 2's complement, we said that it is minus 8. Similarly, you can take out any number by changing its MSB. From 0 to 1, you will get it as sign and magnitude. By complementing each of the bit, you will get it as 1's complement. And by adding 1 to the 1's complement, you will get it as a 2's complement number. You can see, you can take out any number over here and you can find out the difference. For example, take out this minus 5. Right? So you can make the difference between plus 5 and minus 5 here. This is the plus 5 you have and this is minus 5. So the number is here, representation, binary representation. For the plus 5, MSB is 0 and for the minus 5 MSB is 1. Right? Now the same number will get you 1's complement in, the same number will get you minus 2 in 1's complement and minus 3 in 2's complement. We will check out how we can do that. It is, the number is 1, 1, 0, 1. 1, 1, 0, 1. 1's complement you got it as 0, 0, 1, 0. So this I will get it, this is represented as minus 2, right? Here, minus 2. Now, if you add this number, if you add 1 to this number, you will get minus 3, which is the representation in 2's complement. 1, 1, 0, 1. 1's complement is 0, 0, 1, 0. To get the 2's complement, add 1 to this 1, 1, 0, 0, which is minus 3 we say in 2's complement form. This is 1's complement form. So this is how you have to represent the number in computer system for different methods. Maybe it is sign and magnitude, 1's complement or 2's complement.